Alright, hello, my name is Alvaro. I'll be doing a series of videos in my channel in English about the subject of second SO physics and chemistry. This series of videos are intended to be as side material for the course I'll be giving at my school. So it's basically, so if you missed a class or you've got any problem um, at school and you couldn't be in class that day, you had the material, at least the most important things we did in the class that day. It's going to be, as you will see, they're going to be faster videos than they are in class, because we can much more easily get to the point, and we're just going to be covering the main topics, or the main theories, right? So first of all, I also wanted to say that sorry in advance for my English, because English is not my first language, and I'll probably make a lot of typos. Sometimes it's going to be a bit difficult for me to get the message through, but I hope it's not terrible and we can learn some science. In this first video, we will be talking about what is physics and what is chemistry. Basically, the two subjects that we're going to study. So physics versus chemistry. Okay, these are the two subjects that we're going to study in this course. And we first of all, we want to learn, or we want to know, what are the sciences interested in. And basically the points are as follows. Physics is a science that is probably the most general science that there is. It's a science that tries to find the universal laws for how matter interacts, and is not so concerned on specific things. For example, biology is concerned only on living creatures. Geology is only concerned on rocks, on how these rocks are formed, are transformed. Chemistry is trying to understand how substances interact. We will see this later, at an atomic or molecular level. And physics is more like a science that tries to see the grand scheme of things. So physics is the science that wants to find general laws, and these general laws are then going to be used by other sciences to develop new theories. All right, and it's basically going to talk about matter, energy, space, time, and how these things interact. Okay, so matter, space, time, and matter, space, times, and energy. Sorry, and energy. Okay, this, however, physics is the second subject that we're going to study in this course. We're going to start basically with chemistry, and once we've developed some theory about chemistry, we will enter in physics. And then we have the other science that we're going to study in this course, which is chemistry. And chemistry basically focuses on studying the composition, the structure, the properties, and the changes that matter experiments, basically at an atomic or molecular level. Atomic and molecular level. Which means, basically, that chemistry studies how atoms interact with each other, how they form different molecules. We will study, for example, why a molecule of water has one oxygen and two hydrogens, what's its geometry, why is its geometry important in the forces between different molecules of water, and so on. So, having made this first difference between physics and chemistry, the next thing that we need to learn in this course, in order to really start it properly, is to remember what's the scientific method, because the scientific method is a process that all sciences basically use these days to try to understand the world around us. And so, since we're going to be studying two different sciences, then it seems important to know what the methodology of these sciences is. Okay, so, and with that we finish this class. As you can see, it's pretty fast class. Okay, we're going to look for the scientific method now. Scientific method. Okay, so the scientific method is a methodology that's basically developed on the 17th century. Before that, we can't really say scientific method was applied as we know now, and obviously it has been changing lately with the development of the internet and so on. But basically the idea is, before the 17th century, it didn't have a clear structure. Sometimes it wasn't really focused on its main goals. But from that century on, we can see some changes on this methodology that really changed how we make science and how we do science. Basically, science starts being important around this year. Scientific method has some steps. These steps are not as rigid as you may think. It's more important to think about why the scientific method is important, is powerful, and those would be the characteristics, or the key characteristics of the scientific method. We will start with that because I think that it's more important, and then we'll go through the steps of the scientific method. Okay, so why scientific method is good? Why is it a good tool for humans to gain knowledge about the world that we live in? Well, first of all, because it's systematic, which means that it follows always the same logical progression throughout their investigations. And so it can be applied to many different fields, always in the same form, which is basically makes it easy to replicate, makes it easy to make by different people from different cultures, and then share the results, because everyone is trying to work on basically the same system. Another good characteristic of the scientific method is that it is objective. Objective is basically its objectivity is what separates science from philosophy in the ancient times. It basically aims to minimize personal bias. This doesn't mean that scientists are not affected by their biases. They of course are, because all humans are affected by their biases. But if we want to make good science, we need to be as objective as possible, trying to only rely on the facts that we are seeing. Next characteristic of the scientific method would be that it is empirical. This is also key, and another key difference from science and philosophy is that science is only based on actual facts that occur on the real world. We're not concerned about what happens in an ideal world, which means that basically we can theorize and make guesses about what's going to happen when we do an experiment, when something takes place, how is it going to happen. We can theorize about all those things, but the last word, it's always on reality. If we make an experiment to test our hypothesis, and the experiment shows that the hypothesis is wrong, then that hypothesis doesn't have any value. We're only concerned about hypotheses and that have empirical results. And as I say, always we have to see that the last word is on the reality, on reality. Fourth point, important point for the scientific method, it is replicable, sorry, replicable, which means that many people can do the same experiment, and those many people all have to get the same result. Experiment has to be designed in ways that other scientists can redo it and really test if it is correct or not what was done in a certain experiment. Sometimes in science we find that some scientific investigations are published that are really difficult to really replicate or find the same results, and very fast these investigations fall into oblivion and get discredited, because if a result cannot be replicated, then it's likely that that result is false. It's not scientific, because if we know for a fact that something happens when we do a certain experiment, then that something can be done as many times as we want. This is basically, or the replicable part is basically the part where social sciences find the most struggle, because social sciences work with humans, and systems of humans are really complicated and difficult to replicate because they depend on so many variables. And in this case, we could say that replicability is a characteristic of natural science more than science in general. Okay, so it's important that our experiments are replicable, but it's more important, or I mean super important in natural sciences. In social sciences, it's not, I wouldn't say it's not as important, but it's not as possible. I would say it's not as possible, because sometimes it's difficult to really replicate exactly experiment in social science. And finally, the last point that I wanted to go through is that it is iterative, and this is fundamental. Iterative. This is fundamental because it means that once we get a result from an experiment, that creates new leads to make new experiments. And so we build scientific knowledge from the knowledge we already have. We build on top of that, and we build on top of that, and we build on top of that, making progression much more efficient than if we needed to start from scratch every time. So these are the 5 key characteristics of the scientific method. This is why science has been so successful in the last centuries, in knowing the world around us, in understanding the world around us. It is systematic, it is objective, it is empirical, it is replicable, and it is iterative. These 5 characteristics make the scientific method an extremely useful tool to really know the world around us. I will go very fast through the steps of the scientific method, but as I say, this is a bit more important than the steps. The steps of the scientific method would be, first of all, we would ask ourselves a question. We're beginning with an observation that we saw in the natural world. And step number 2 would be doing some background research to know what is common knowledge about that certain observation that we're interested in. So that's where the iterative part comes in. We basically need to find what has been done before on that same topic, so we don't waste our time in doing something that already has been done or we already know for a fact. Then after that, we could formulate our hypothesis. A hypothesis is a testable explanation. The hypothesis is a very important concept. I will write this down. Hypothesis. The hypothesis is a very important concept in science. It's basically an explanation for what will happen and why does it happen. Okay, so if we observe a certain thing and we think that thing can be explained throughout a certain um, set of steps or different ideas, then those ideas must come or condense into a hypothesis, which is an explanation for what will happen and why, for what will happen and why, and why. Okay, this is key in science. For example, um, if I try to if I like plants, for example, and I am curious about how adding mineral salt to the plant, um, how is that going to affect the plant? Is it that going to be good for plants? Is it going to be bad for plant? You know, you probably know that there are different fertilizers that help plants grow, and so you may think for yourself, okay, if I add salt on the soil of the plant, then maybe the plant will grow better, bigger, stronger, right? If salt is a fertilizer, right? So my hypothesis for that experiment that I can make would be something like, if I add salt to a plant, the plant will grow bigger, better, stronger. That is an explanation for what will happen. And why? I have to explain also why does it happen. And I will say, because salt is a fertilizer, because salt helps the plant get the nutrients it needs in the earliest stages of its life. And then I can start, once I test that, I can start doing more experiments to maybe understand better that process of why the plant grows better with salt. I'm not saying that plants grow better with salt, it's just a hypothetical hypothesis. But that's the idea of a hypothesis, okay? It has to be an explanation for what's going to happen when I make my experiment and why does it happen. So that would be the step number 3, form a hypothesis. And then we'll go to step number 4, which is basically doing the experiment in which we test our hypothesis. We design and conduct experiment to collect the data that will support or refuse the hypothesis. We will see in the next class more about this experiment thing. Because designing a good experiment is also very important for science. And finally, when we finish the experiment, we need to analyze the data we've gotten. That's step number 5. And step number 6, we have to draw a conclusion from those data. Is the hypothesis wrong? Is the hypothesis correct? And finally, we could add a step number 7, which would be communicate those results to the scientific community. That step number 7 is basically a fundamental step in professional science, but it's not a fundamental step in science you can do at home, because you don't really need to communicate your results to anyone. But it's true that nowadays science really works with that communication at the end, basically because this iterative part, and because we as we said, we need to learn what has been done about our area of interest first, so we can start building on top of that. And so if we don't communicate the result of our experiments, then the scientific community cannot know what has been done in that area of research. And so those steps are basically working on the communication and the iterativity of the scientific method. So with this, we've ended the first class. I hope it was useful for you, and we'll see you on the next one. Thank you.